This is critical thinking in the Special Senses Lab, and here are the questions. Here is the first one, the second one, and here is the third question. So let's go back and look at these questions individually. So here's the first question where it asks you, damage to the sense organ shown here will interrupt what type of sensations, and which part of the central nervous system will they fail to reach? In other words, those sensations will fail to reach which part of the central nervous system. Now, when you look at this sense organ here, this sense organ is the macula, which is present in the saccule and utricle. So the sense organs are present in the membranous parts of the structures in the internal ear. For example, the saccule and utricle and the semicircular ducts and the cochlear duct. Now this one happens to be the macula present in the saccule and utricle, and this is responsible for equilibrium. So therefore, the type of sensation that will be interrupted would be equilibrium, which is this one. Taste is carried by taste buds, which are present on the circumvallate and the fungiform papillae, so it's not taste. Hearing is in the organ of Corti. This does not show the organ of Corti. Smell is in the olfactory epithelium. That's the sense organs present there, the receptors. Vision, you have the rods and cones in the retina. So this is equilibrium. And so hence this is the answer here. And which part of the central nervous system will they fail to reach? It will fail to reach the cerebellum, because equilibrium carried by through the sense organ and then carried by the vestibular nerve goes to the cerebellum. So therefore this is the right answer. Also, if you notice in this, all of these other sensations, the lobes or the parts of the central nervous system associated with them are mentioned. So taste is in the parietal lobe, even though they are not the right answer. Hearing is in the temporal lobe, smell is also in the temporal lobe, and vision is in the occipital lobe. So this is a good review here. Now let's go to the next question, which tells you that a blockage of A due to wax can lead to what? And why do you direct the flow along the roof of the external auditory canal when syringing for wax removal? Sometimes when wax gets impacted in this area, A is the external auditory canal. When wax gets impacted over there, you need to remove it, and you syringe the ear by passing water along that so that it can then float out. So it says, why do you direct the flow along the roof? So in other words, when you're syringing, you want to direct the flow of water along this part here. Water, sometimes you may put hydrogen peroxide. So you want to direct the flow along there. So the first is, what is blockage of A due to wax going to lead to? So let's look at the choices here. So the first one says loss of equilibrium, and this is not true because from here, so this was not true. A, which is the external auditory canal, conducts sound impulses. Equilibrium is a function of this, the semicircular canals in which are present the semicircular ducts, and then in the vestibule you have the saccule and utricle. So hearing loss, that is true. That's what, if there is wax present here and it blocks that, usually any foreign body or wax tends to get impacted at the isthmus, which is the narrowest portion where bone meets cartilage. You can see sound waves which are coming from here cannot go and hit the tympanic membrane, causing it to vibrate and then passing it along the three ossicles through the stapes and then going into the cochlea. So sound waves are interrupted, which means there would be hearing loss. So hearing loss is a choice. So we have two statements which have hearing loss. And it says, why do you direct the flow along the roof of the external auditory canal by syringing for wax removal? So let us look at what this, it says it is shorter in length. Now the roof is not very much shorter in length than the flow, so that's not the answer. So let's look at the other answer. So it says to avoid stimulating the vagus nerve. So this we had already said was the first part was right. And the second part is also right. The reason is that the vagus nerve sends a branch which travels along the floor of the external auditory canal, supplies this area. So when you syringe the ear, or you pass anything and you stimulate this region, you stimulate the vagus nerve, and the vagus nerve carries with it parasympathetic fibers. And these parasympathetic fibers, when stimulated, can lead to a lowered heart rate, and that the person may even faint. Or because the vagus supplies the gastrointestinal tract, it can lead to nausea and vomiting. So therefore, you don't want to stimulate the vagus nerve here. Hence, you direct your flow of fluid along the roof so to avoid stimulating the vagus nerve. Hence, this is the right answer. Let's look at the third question, which says blockage of which of the structures labeled below could lead to glaucoma. So the first thing is glaucoma is due to excess of aqueous humor. And aqueous humor is produced by the ciliary processes in the ciliary body. And so it's produced by these ciliary processes, and then it is drained through a canal which is called the canal of Schlemm, or also known as the scleral venous sinus. Now this E are the ciliary processes, D is the iris, E is the lens, A is the anterior chamber, and C over here is this canal of Schlemm or scleral venous sinus. So it says blockage of which of these structures could lead to glaucoma. So we can see that the ciliary processes are producing the aqueous humor, which passes out. So it passes through this pupillary area because the gap between the iris comes into the anterior chamber, and then it has to be drained through this scleral venous sinus. So if the scleral venous sinus is blocked due to any reason, drainage cannot occur. So this will keep producing that, and it will get into the anterior chamber, which will keep filling up, but it cannot be drained, and hence that could lead to raised intraocular pressure, which leads to glaucoma. So it would be blockage of C. So we can say anterior chamber can't be blocked unless theoretically we have something where the iris completely is adherent to the lens, but the best answer is C in this case. So it's not A. B, as I said, was the ciliary processes. They don't get blocked because they are processes which have epithelium which produces the aqueous humor. D is the iris, so it's not that either. The iris doesn't get blocked, and E, the lens, doesn't get blocked. So it is a opening which gets blocked, and that opening is that of this scleral venous sinus, which you can see here is C. So the answer is C.